I'll get started just to not slow things down. My name is Carlos Garcia. I'm with Optum, part of United Health Group. So Optum does a lot of the kind of more the services side of the house, doing a lot of healthcare services. So today I'm going to talk about authentication authorization for clinical microservices and kind of get into our experience, our lessons learned, in implementing really specifically fine-grained authorization over clinical APIs. So to start, kind of the project I'm working on is a deployment of a genomic medicine service used more for routine type of clinical visits. So the whole concept of you go to your doctor, and if unfortunately you have a rare disease or a cancer, the ability to do a whole genome sequence. So if you start looking at this, is not on the patient side, security or solution for them as much as it is for the clinician side of the house. So the type of applications that we're talking about here would be for test ordering, for being able to look at results and be able to do some of the analysis, interpretation, the different panels around gene sequencing. So you have multiple types of users, clinicians. Again, those that are taking the sample. Think of everything from the wet lab experience all the way to getting the final results, looking at your genome sequencing, and going back to the doctor who's looking at, what hopefully identify what kind of rare disease or cancer you have in order to, start the appropriate type of medical care. Including things as researchers as well, those that are actually looking at the data, doing the interpretations, researchers who, the more genes that are sequenced, the additional amount of genomic data in order to do more analysis and, hopefully discover more cures for us. And so what we built was a kind of modern-based application. So looking at it from microservices, everything containerized, everything RESTful APIs, implementing an API gateway to front-end all the microservices. So I think of it just from a developer point of view, using kind of modern architecture around the application. So at a high level, we're talking about a lot of single-page applications during REST calls into the back end where all the microservices are. Microservices tend to have their own, individual databases. All of this within a containerized environment. For us, we're using, those familiar with it, OpenShift, but this would apply a lot to standard Kubernetes type environment. So next was getting to so how do we handle authentication authorization? And this is where we really talk about, what were the constraints we had or the considerations we had as we were looking at building out this kind of test ordering genomic system. A lot of the clinicians that we're dealing with, a lot of the providers, if you will, we already had within an Azure tenant. And so the last thing we wanted to do is go through another registration process, to enroll identities and so forth. We wanted to stick to standards, so OpenID Connect, OAuth, Xactimel. We wanted to make this as developer-friendly as possible in order to do that, sticking to standards. So we wanted to make sure this was portable in the sense that regardless of the roadmap to our identity providers, if this solution was sold as a package to a different entity, you could implement it without having any kind of proprietary standards that make it, a difficult implementation. So as mentioning, you have the front UI, single-page app that, has the implement OIDC clients, and then the back-end applications where, in essence, we're using the API gateway as the resource server within your traditional OAuth flows. So the notion was, to as much as possible abstract the security from the microservice layer so that the developers are focused on building their applications, building the value of them, and not worrying about each different, application development team doing something slightly different and expanding the scope that you have to worry about, making sure they're following the best, OAuth implementation practices. So it's not to say that there wouldn't be a case where we would implement security at a more granular level down at the microservice, but as a general rule, our approach was let's try to abstract as much of it as possible. Depending on the APIs, we had a large range of everything from really kind of basic authentication, because everybody we're talking about here is going to be a clinician within a closed ecosystem, So everything from just basic authentication, allowing you into some applications to be able to view the different kinds of genomic panels you might want to test against, to kind of that coarse grain where it's based on your capability, to fine grain, which is really based on that context of who you are and what you're trying to do. And of course, one of the key things is, make sure this is fast. In the microservices world, you just got to make sure that you're not deploying, modern architecture with some legacy IAM solutions that slow things down. So starting with authentication, kind of the most broad grain authorization. We basically created a tenant within our Azure environment so that all the clinicians would be there as, the Azure terminology, B2B guest. Basically federated the identities over to our tenant. So that way we're able to kind of manage all the different attributes or, the roles that would be used for our authorization rules. At the UI level is where we configure the OpenID Connect clients to talk with Azure, which is our OpenID provider. And then we standardize on the Kong API gateway. It's an open source gateway, big fan of it at Optum. And we created a custom authentication plugin. It's basically an OIDC plugin with a couple of extra features that we wanted to add to it. We used it specifically for Azure, but it's, it would work with any other OIDC provider. And to top it off, we use YubiKeys as the second factor. Again, this is for providers, physicians, clinicians, and so kind of mandating that kind of a strong second factor. It's actually the 140 keys that we used, which got recalled like days after we started deploying them. Anyway, so next, getting into kind of the coarse grain. So great, there's, the basic authentication. Now, if you want to do some level of authorization, so this is where we start looking at the, the ID token we're getting from Azure, and within it, we have the information of what claims we can use within it. As a guidance to what APIs, what are those API routes that you could create some action against. So this same custom plugin that I created, we put some really kind of rudimentary ABAC controls within it. And a kind of example, we have both white and black lists that basically says, hey, if you have this role, you're able to do a get, a put, a delete on this particular resource, as long as you have this role. So example, again, this is like, I'm part of a doctor team, a nurse who's part of a team that wants to look up a patient record. With this kind of coarse grain example, it's like if I'm trying to do a get on a patient record, it's like, hey, I'm allowed to do it because I have the correct role membership, so that's subject, verb, object. It's coarse grain, there's some control. I'm able to do a get, I'm not able to do a delete, or I'm not able to do a put, whatever, a post. But I'm able to do a get. It's that coarse grain, some level of control. But, and so within it, they're just kind of showing with this plugin, it's basically a whitelist to say, if you have that role of clinician role, great, you could do a get. And likewise, if you have a particular role, you could blacklist it and say, you can't do it, to be very explicit what you can and can't do. So next, really kind of getting to fine grain. Well, that works fine for that coarse grain to be able to get something. That means I could get all of the patient records, right? Great. No, not really. So you kind of get into, well, we want to have more control over that generalized, I can access patient records versus I can access those that I should be accessing. And I keep it simple by just using that clinician role, but you think about it in the sense of the researchers who are looking at data, it's hard to de-identify genomic information because you can't get more specific to who you are than your genome. Right? So, there's obviously things you do within the world of de-identification, but really limiting access to some of this information is very important. So centralizing that policy, having a central point of audit for all of this, limiting the impact of the microservices. We don't want to create a system where, depending on how policies changes, as you have more institutions become part of the ecosystem, as you have different provider networks that get added to this system, you don't want to have to redeploy business applications, these microservices, business in the sense that, they're part of the medical service. You don't want to have to redeploy them every time there's a policy change. So being able to extract that as much as you can. We looked at it from the point of view of enforcing it at the API gateway. Again, is this a solid rule, like everything goes through it or does it? No. It was one of those that as much as we can, keep the security enforcement out of the microservices and handle microservice security in a different manner, but the authorization of it at the gateway, we're having all the traffic funnel through one place. But this is not like, you must. If there's exceptions to the rules based on the requirement. At the end of the day, what is the best way to make sure we get the fine grain? Importantly, of course, a lightweight solution. You're not going to build this microservices model, this architecture, and then stick some, humongous PDP in your environment. So the way we approach fine grain is we ended up using the Axiomatics Access Decision Service because it's basically a microservice. So we're able to deploy it within the, again, Kubernetes namespace, or in my world, it was an OpenShift project for the fine grain authorization. So it's within it's essentially a container that's deployed alongside of all of your other containers, your pods. Furthermore, we created this Kong plugin that is able to make the calls, again, at the gateway as the requests come in, to be able to do the call to that microservice to do the permit or deny. I'll mention, you hear a lot of me about creating these Kong custom plugins. I mean, again, there's a reason we love Kong a lot, and I'll get into that later on, but plugins are awesome on Kong, very easy to do. So that fine grain authorization, and we go back to the example of, hey, me, clinician Carlos, is trying to look up a patient record. Now it's more specific to get this patient record. So I'm allowed from the previous clinician role that I have, but now it's adding the notion of that context. Do I have a relationship with that patient? Am I part of the same medical team that's, helping this patient with this particular rare disease, this cancer? And so that's where you kind of get into, okay, great. We know that you have access to do that get, excuse me, based on that earlier that claim that we used for role-based. But now combining that role-based with kind of that attribute-based together to kind of extend your coarse grain level over to a finer grain, now you're able to take additional claims from that Azure identity token and say, well, what else do I need to know about you for this particular policy lookup, whether it's the group, whether it's identities, whether it's the provider group, member number, something, additional attributes that make sense for the context you're trying to do. Now, the Kong plugin will collect these claims and also the resource, so that, that object, right? There's me, the subject, I'm trying to do a get to this endpoint, and it's able to take that information and send it over to the authorization microservice. The authorization microservice, because of the authorization policy that's been deployed within it, is able to then, go through those claims, put them together and say, yes, Carlos is allowed. He does have this relationship with this record ID that you're trying to look at. I have this flow. I'm not trying to, the people in the back probably won't be able to see this, but from the reference point, if anybody wants to see these slides later on, it basically takes the one-by-one step flows from the clinician at the browser, your typical OIDC flow to Azure, OAuth along the way, and Kong making some calls out to the authorization microservice. Or if somebody really wants to see it afterwards, I could show it to you on my laptop. So how did we create and deploy the fine grain policy? Now kind of getting more to like in this microservices world, how did we do this? So creating the policy is very similar to how we would do it in any other type of deployment. From the point of view of Axiomatics, we used both the UI, the service manager, and later on started playing with the alpha, but basically to write out what the policy would be like. And the difference being that, at this point, you do the same things you would. You connect to your PIP. You're able to say, hey, this policy, you go to this microservice database, this application database, to find that relationship. This is where we store the relationships of the doctor team to that patient. So that's where you'd be able to get that ultimate verification. Once we define that policy, we essentially just export that policy in a format that's, it's understood by the microservice. And for those familiar with, again, Kubernetes, OpenShift, we basically export it into a config map. A config map, again, the 2-second version of it, it basically, when you have multiple microservices, instead of having to manage COM files or license file or a policy file, which each one of those, containers, you're able to kind of export them into these config maps where you have this kind of common configuration that when a pod is deployed, it's able to kind of consume it at runtime. It's like, oh, I'm starting up. I know that my configuration files are at this location, suck them in. And that way, you're able to change the config files without having to change the actual containers you're building. So that makes it very dynamic from the point of view of, again, if I have an environment where I'm making changes to policy, but I'm not I don't want to be redeploying the same application all the time, hard coding, the policy within an application, config maps are just, they're perfect for that. And it fits really nicely into our CI/CD model. Everything we do kind of goes through, storing it, whether it's pushing it out through Jenkins, creating our images, and using Ansible to create all the configuration maps. It fits nicely. It's a really kind of great lightweight service for us. So we deploy the microservice. At runtime, it's able to read the config map and get its authorization policy. So now it knows everything about that security domain that you're setting your policies for. It's aware of the databases that it needs to go look up for particular policies. So again, at runtime, when you make a post to it, taking the claims information, taking the context, taking the target API endpoint that you're trying to look up, it's able to quickly do that analysis and come back and give you your permit or deny. This model is really nice because, again, depending on how complex your environment is, you might have different, it's called security domains within your namespace. Depending on how you architect your microservices, you can maybe have all your policy within one policy set that you deploy to one microservice, but of course, pods and elasticity. It's not really one pod, but it might make sense that you're like, I'm going to split up my security policies. I'm going to have essentially 2 authorization endpoints. It's completely doable with this model, and it's a nice way of, separating those security architecture. So that's kind of how we put things together. So the final part is really kind of lessons learned. So what are kind of the things that we went through that we learned? One of them was engaging the development team early and, quite frankly, doing a lot of the heavy lifting. One was there's a lot of misconceptions about Xacaml, where it is now versus where it was. So, walk into a room with a bunch of developers who are working on REST, JSON, maybe Java, JavaScript, different languages, and you're like, hey, we're going to use OpenID Connect. They're like, yes. We're going to use OAuth. Yes. You're like, we're going to use Xacaml. And they're like, what? I'm creating this beautiful JSON REST application. You want me to do SOAP? You want me to give me an SDK to create this PEP? And it's like, oh my God, no. And so it's really, we had to start with like, hey, Xacaml's come a long way. Let's not talk about Xacaml as much as, don't worry about the name of the standard, but really attribute-based access control and what it looks like and how you're going to access it. So looking at it from the point of view of like, oh, it's just a microservice at the end of the day that I could call out as a developer if I want using JSON, REST, POST, something I'm very familiar within my development world. It's like, okay, I'm not scared of that anymore. Because ultimately developers are, I've gone through this show before. I mean, I've gone through fine-grained authorization attempts to get it implemented, and at the end of the day, it's the developers who are always going to be like, oh, this is too hard, I don't have time for this. And so making it as easy as possible. So educating on the approach to make sure they don't think SOAP is involved in any way. The second part of it is, understanding their APIs. We went through and their Swagger UIs, a couple of hundred API endpoints, and really kind of mapped them all out and created these, Excel spreadsheets where essentially it's we have a defined set of clinician roles, researcher roles, and whatnot roles, and we have all these different endpoints, and really just going down to like, okay, if you want coarse grain, these are the roles, these are the routes that offer that coarse grain. And if you want fine grain, these are these endpoints. And so it's really kind of almost creating a template that takes that whole notion of that subject, who's the subject, who gets access to this, plus the verb, the action. What do they do? Can they do read? Can they do writes? Again, that object, this test order API, this referral API, this patient API, whatever it might be, the kind of data you're getting access to, and then the context. What are the rules around it? And trying to keep it at that almost like a simplified English level of just like, put in these characters so the clinician gets access to a referral as long as they're part of this network and they're part of this. And so really kind of drawing it out that way, it certainly made the conversations a lot easier because it took away I got to look at my APIs, I don't have time for this because I'm busy deploying, to really kind of presenting their own information back to them in a kind of mapped out way. And that kind of ties into the last one of just focusing on business requirements, of kind of just trying to be, at the end of the day, we really played a role of being arbiters of talking with the business who kind of have these vague notions of what type of policy and what we need to be protecting, and really kind of the development community that basically creates these endpoints and trying to, manage the conversation between the two of them, and to simplify in each of their languages, to really draw out, this is what a policy should look like, can look like, in order to make this successful. So getting short on time, but yeah, so that's what we've done. There's still a roadmap involved. We're not completely done. The other thing too is a quick shout out for, again, coming from Optum, we're very much devoted to open source. A lot of these plugins that I just mentioned, I keep mentioning too because we're giving them back to the community as open source plugins. This is just a handful. We've done plugins for logging, for a bunch of different things. The two that we're still working on, those are the current Optum employees that have done them. Eventually, as they kind of go through internal process, they'll end up in our Optum's official GitHub. So if you're familiar with Kong, if you want to talk to me about Kong versus some of the previous legacy vendors that we worked with, happy to talk about that. And finally, the last thing I'll add is also for those here in healthcare, we are also really committed to the notion of a clinical open source alliance, working with other healthcare companies to find ways where we can collaborate. And creating a plugin for a gateway is one thing, but really open sourcing some of our own, as technology companies for healthcare, of open sourcing our own solutions and collaborating with other healthcare companies to do the same. It's something that we're very much interested in doing and very committed to doing it. So please reach out to me if that's something of interest. With that, any questions? Yes, sir. Oh, thank you.
Yes, my question is, why did you choose a microservices architecture over a more traditional monolithic architecture?
We don't want to have a big monolithic, because actually the part of this application, the legacy of the application came from some research monolithic applications that were initially created. And so taking that monolithic approach and knowing the limitations of it, the fact that it's big and heavy, it's not lightweight, it's not easily portable, you can't make changes, when you're looking at a roadmap of trying to define all these services, the monolithic approach was just not, over and over, we've seen it with all of our different applications, it's not doable. And so across the board, across all of Optum, we're going through that difficult process of just trying to go through that legacy to a modern architecture.
Do you have different flows, like accessing your credentials and you get your password and stuff like that? Or is it just straight authenticating a user or service to service?
Oh, the question was, do we have flows for authentication and forgetting passwords? In this case, we're lucky. So that's actually part of our roadmap to figure out as we start looking at other outside entities, because we had this, that was solved for us. So there was the existing Azure tenant of all of these clinicians already have O365. They already have that figured out. So we're almost like a relying party that was going to do our own we're going to take care of coarse grain, fine grain authorization, and we're going to add a couple of roles in Azure, and we're going to make use of YubiKey, but essentially we're taking your identity that you've already established for the rest of the, the provider network. So.
What tools do you have for testing your fine-grained configuration rules so that you don't roll out a new config map and take away access?
Oh, okay. So the question was, what kind of testing are we doing for validation of our fine-grained authorization rules? Good question. Please run into me. I'd love to answer that question. Testing is definitely, definitely a lot of testing. We have a dedicated testing team. In regards to the tools you're using, I don't know off the top of my head. You bring it up funny because I requested a test and they're like, yeah, we'll get you set up on, Grafana and Jenkins so you could run your own tests. But under the covers how they're doing it, that's a good question. I don't have. A lot of it goes back to the methodology of what we're testing. I could talk to you more about that in regards to how we really map out those templates that we created to really map out those API endpoints and the permissioning required, and test based on that was helpful. I think I'm totally out of time, but I'm here till Friday. Thank you.